Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Welcome to another episode in the Chai Time Data Science Show. In this episode, I interview Pierre Stock, currently a resident PhD student at FAIR Facebook AI Research Lab, Paris. Pierre has a background in math and machine learning with a master's degree in computer vision and ML. He's currently a resident PhD student at the Facebook AI Research Lab, and his interests for research include large-scale learning, neural network compressions, and AI safety in general. In this interview, we talk a lot about his research and deep learning research in general, the work and research process at Facebook AI Research Lab. We also discuss about his recent research preprint titled quote unquote, and the bit goes down, revisiting the quantization of neural networks. You can find a link to the preprint in the description of the podcast. If you enjoy these interviews, please feel free to subscribe to my newsletter. You can find a link in the description. I release 2 interviews each week on Thursdays and Sundays. For now, here's the interview with Pierre Stock. Please enjoy the show. Hello, Pierre. Thank you so much for taking the time to do this.
Thanks. It's my pleasure to be here. Thanks for having me.
So you're currently a resident PhD student at FAIR, which is Facebook AI Research for the listeners, Paris. And you have a background in math and machine learning. So could you tell us how you got started in machine learning and what got your interest in the field?
Yeah, so basically I would say I have a very classical path up to my master's degrees. I did the French class préparatoire and an engineering school.
Mhm.
So basically I have a mathematical and engineering background. And I think what really got me to ML, so machine learning, is a desire to have a vast playground with like a fast-paced field and also challenging problem and the potential impact on the society.
Okay.
And I always remember when I was young, I wanted to build things like with Mechanos. I don't know if you know the name. Is
I do. So the mechanics toolkit, right?
Yeah, exactly. So you have like metal stripes and gears, and you want to connect them together.
I think it's a metal logo, Lego, if I may call it that. So metal version of the Lego blocks of sorts.
Yeah, it was not. Yeah, it's kind of. So I loved construction games, and whenever we came back from vacations, I built whatever thing I saw, like a bridge, an Eiffel Tower, or whatever. So I think I do the same with ML. I build things and I get to playing with them. So it's kind of nice.
Okay. And I'm also curious, like, so you followed the quote unquote traditional path, which is like a bachelor's followed by a master's followed by immediate a PhD degree. So what made you pick the research path over the industry?
Yeah, so actually I would say at FAIR you get to do both research as in any academic lab, but also you can work with projection teams, and, for example, to scale up your approach or to incorporate their constraints into your research. So this double aspect is very exciting for me. It's something very unique, I would say. So just to say that research and industry aren't mutually exclusive.
Mm-hmm.
And more generally, I think like in research, you are judged by the work you publish, by your peers, and not say by your prior education. So it's both positive and also very challenging.
I think it's also because you're working at FAIR, so sometimes like there the boundaries must be blurred.
Yeah, sometimes the boundaries are kind of blurred. What I really like is that you have the liberty to choose, and depending on your interests and whether production teams have the same interest as you at a given point of time, you can work with them, and you can also work on like more long-term research. It's totally up to you.
Interesting. So I'm also curious. Could you tell us more about the Fair Lab at Paris? Most people think that the quote unquote AI scene is in the US area or the Canada area. Could you also give us an inside scoop on how are things in Paris and the European area for the AI scene?
Yeah, so it's true that the US is undeniably one of the centers of AI, along with Canada also. But I would say that first in Paris, FAIR is one of the biggest labs. FAIR
Mhm.
Paris is one of the biggest labs in FAIR.
Yeah.
I would also say that the setup when you're a PhD at FAIR Paris is quite interesting and quite special. So you get to partner up with an academic lab,
Okay.
and then you do your PhD with both FAIR and the academic lab.
Okay.
I have two supervisors, actually three, but one supervisor in the academic world and two at FAIR.
Okay. So both you have multiple advisors for your current
Yeah,
research.
and this collaboration with French academia is very interesting and very key for FAIR actually, because you get to partner with the best researchers while they stay still in the academic labs.
Got it.
So, and the AI ecosystem in Paris is kind of quickly densifying. So you have lots of startups being created, and also almost every major companies recently opened some labs. So you have Google Brain with
Yep.
people such as Cornelia Schmidt. You have DeepMind with Rémi Munoz, who's coming back to Paris. You have also Uber with François Sillon. So it's pretty exciting times to be in Paris, actually, I would say.
Interesting, indeed. So I'm also curious. Could you tell us more about what does a day in your life look like? So how does a day in the life of a PhD student at FAIR look like?
So basically, I usually wake up in the morning and check my logs. So basically, check how the experiments I ran in the nights went.
So you
And then
leave the models running overnight and check the output in
yeah,
the morning. Is that
I try to do that because otherwise I just keep looking at my logs all day long while the model is training. I think it's a common fallacy in the ML researchers. You just stare at your logs.
something very interesting about watching the loss curves go down and stuff like that? So for sure.
Yeah, yeah. And it's you are waiting for the next epoch to get better and not doing anything particular. So I think one thing which was very productive for me is to run the experiments at night when I sleep,
Okay.
and then just change the final logs in the morning. Then I launch other experiments depending on the outcome and on what I want to do.
Mhm.
I spend most of my day like prototyping. Sometimes doing also more theoretical work with like a paper, pen, and equations.
Mhm.
I would say I don't read as many papers as I should do. So this is
Okay.
something I have to work on, but it's crucial to keep with the fast pace of the field. But I have to admit I don't do that enough. And also I discuss with my colleagues a lot. We play babyfoot, so it's a
Okay.
nice break. But also you can talk about research while playing babyfoot or while having lunch, and also Twitter. But I think everyone does that.
uh, a common question that I want to ask you that is also common in the community is that how does a research pipeline work? So how do you approach a new problem, and what are your go-to steps when, for example, you think of an experiment, and what questions do you ask while when you're about to start on a problem?
So yeah, it's basically how do you do research? That's a very vast questions. I would say by setting two things that my advisor at FAIR told me, which are very interesting. I think the first thing, you have to be curious about the problem you are considering, because curiosity will be one of the main drivers for your discoveries. So if you're not curious about what the problem, is not worth investigating, at least for you. Second, you have to really like the project you are working on. So it should be obvious, but if you don't like the project you are working on, it has way less chance of being successful because you won't put as much effort as if you are like passionate by the project. So,
Because
and one
in machine learning, nothing works until it does. So you have to have the patience
yeah,
also and the
exactly.
passion.
So once those two conditions are basically met, so once you are kind of obsessed with some problem, then you can start basically the research itself. And I think the most important thing is to be able to prototype very quickly. I personally use PyTorch, so I'm being corporate here, but I think it's awesome. And really, you should pick the library you are the most used to and comfortable with,
Mhm.
and also write code as clear and modular as possible. I know it's not always the case, but I think you progress when the projects, when you accumulate many projects. For example, my first project was terrible in terms of maintaining code. So you learn from your mistakes, basically, as everyone. And the second thing would be to prioritize. I don't know the exact English term, but basically, you have to balance what time and effort it will take you to implement, let's say, some feature you want to test,
Right.
and the potential impact and the expected impact it will have.
Okay.
And the third thing is to follow your gut feeling. I often, you have since you work like 20, like a lot of time on your project, you have a feeling of what's going to work or not.
Right.
And something feels wrong, you have to investigate it basically, and maybe you will find something interesting on you. Or at least maybe you have some things that work or that does what you think it does.
Right.
But I think following your gut feeling is a very nice thing you have to learn, especially when you're a student, because you have a feel of what's going to work or not, and you should mix that gut feeling with the advice from your advisor. And often it's the truth is in between, basically.
Got it. Also, you mentioned about being passionate about a problem. So there's this thing about being completely obsessed and knowing when to put a stop. So how do you keep a check on if maybe the experiment would totally fail, or if you're maybe wrong about how you're approaching it?
Yeah, so I think that's one of the most crucial questions when doing research, at least experimental research, like in machine learning. And it's very crucial, and thanks for asking this, because I think it's very important. So the first thing I learned when doing my PhD was to distinguish signals from noise. And it took me like kind of a lot of time to do that. But basically, when quickly prototyping, you want to change something.
Yep.
And you want to get a signal telling me how good the improvement is. And at the beginning of my PhD, I lost quite of time thinking that something I modified was actually bringing improvements, but actually it was just within the standard deviation of the main metric I was measuring.
Okay.
And so basically, when people told you like to perform ablation studies and to report results with a standard tendency, so the mean and the variation, like the STD, it's not for the others. It's not to bother you, but it's essentially for you. So to be able to know if your research is going into the right direction or not.
To really benchmark the idea in a way. Yeah.
So you should definitely check the work done in ML reproducibility by Joel Pino. If you're familiar with it, but it's some guidelines to how to publish an article. But I think most of all, some guidelines for you to do research and to distinguish signal from noise. So that's the first thing, and I think it took me like months to learn. But otherwise, you can hope to do like good research. Right. Second thing is to discuss a lot with your colleagues or your supervisors, because they have an exterior point of view and maybe a less emotionally involved point of view, right. Because everyone secretly wants the experiment to succeed, of course. So it's kind of biased towards the success, but you sometimes don't see the countersign or the downside of your approach. So speaking with exterior colleagues could be very beneficial.
How's the environment at Pierres? Is it all in-house residents or is it also postdoc researchers?
So in the lab you have a bunch of PhD students, a bunch of researchers, some postdocs. So exactly the structure of an academic lab, I would say.
Okay, got it.
Basically. And yeah, the first thing also about failure is to accept that some experiments will fail. It's because sometimes you don't learn at school, basically, because at school you are basically used to getting asked a problem that has a solution, a well-known solution. So it's not a big deal if your experiments don't work. I know it's hard to accept, but it's the essence of research, basically. And I would say out of 10 ideas, if you have one that works and that hasn't been tried by someone else, you are pretty happy. So
okay.
But it took me also a long time to work on that.
I think it's also about learning how to learn, and learning how to research is also that comes into picture.
Yeah, it's learning, but in a way that can be different from school. So the adaptation time could be a bit longer.
Got it. Also want to talk about your research interests, which are large scale learning and neural net compressions. So could
Yeah.
you throw some light on why these are important, and do you believe like these are also relevant to like corporations outside of Facebook, because Facebook like has a lot of data, maybe like this could be important to other areas as well?
Oh, yeah, yes, I do think so. So first of all, I think those two aspects are closely related. So on the one hand, you wish to leverage like all the data you have and all the computing power you have to train like large, big models. But on the other hand, you want to make them available to everyone for cheap, and cheap meaning low memory and also real-time inference time.
Right.
So like quick inference time. So if you want basically to improve your user experience, your autonomous car, your drone, your whatever, you will need such a good model. But you will need such a good model which is as small as possible, of course.
Right.
And with the rise of like augmented and virtual reality, the use of smartphones or drones, compressing neural networks is kind of vital for everyone in the industry that does that uses neural networks. And sometimes people don't realize maybe that when you compress a neural network that you manage to embed in a smartphone, for example,
Yeah.
then you can perform inference on device, so on the smartphone. It means that you don't need internet.
Right.
It means also that your data is going to stay on the smartphone.
It's
And that,
also it. I think one of your other interests is also AI safety, so it also takes care of the privacy issues.
yeah, so because the company has to expose itself by giving the model encrypted in the phone, but then on the counterpart, the data stays on the phone of the customer. So it's crucial for the whole industry.
Got it. Uh, Also, since we're already talking about large scale learning, I'd also like to talk about your recent publication titled "quote unquote" and the bit goes down,
Yeah.
revisiting the quantization of neural nets. For the listeners, this will be linked in the description of the podcast if you want to check it out. So, could you tell us more about the idea behind this research?
Yeah. So first of all, the title is due to one of my advisors. So thanks to him. And
Okay.
the idea is very simple. Basically, you want to leverage a vector quantization technique, and I will explain later what it really is. But basically, you want to leverage a weight discretization technique
Hmm.
that is data dependent.
Okay.
So you want to quantize a particular layer by reconstructing the output of the layer and not the weights themselves. And
Okay.
because you eventually care about the output of the network.
Okay. Got it. Uh, Now, also, could you, if you could tell us about what is quantization in terms of neural nets, and where does it come in the picture for this research?
Yes. So basically, quantization is essentially doing k-means on the scalar or vector level.
Okay.
So for those which are not familiar with k-means, so basically you have a collection of vectors and you wish to quantize them. And you will group together the vectors that are the closest and assign them to the exact same value. So basically you gain storage because you only store one, say, centroid per set of closed vectors, and then just one integer per vector referring to the centroid it is assigned to.
Okay. I know the compression rates are also very amazing, as you mentioned in the preprint. Could you also tell us about your intuition behind why does the compression work here?
Yeah, so it's basically one of the first discoveries with neural networks done by Yann Lequin, which is called optimal brain damage. So it's a paper dating back from the 80s, I think, or 90s. I think the 80s.
Okay.
And basically, it demonstrates that you can remove a lot of connections in the network while retraining the remaining ones and still being close to the original accuracy of the model. It has also been demonstrated by Dunhill et al. In the paper predicting parameters in deep learning. So basically, you keep just one small subset of parameters, and you are able to predict the other parameters of the model. So it all comes down to the redundancy of the parameters in the network. So of course, if they are redundant, you can basically remove others while maintaining the information you have in the network.
I was also lucky to have Tim Detmers on the series. So he's been working on sparse learning, where also he shares this thought that if we can easily like get rid of a few weights without affecting the accuracy negatively.
Yeah, exactly. So the pruning thing, so removing the connections, is exactly equivalent to having sparse weight matrices.
Got
So
it.
basically, when I say removing a connection, it's just putting a zero on it so that nothing flows through it.
Okay.
It's
Uh,
exactly sparse matrices.
Got it. Could you maybe tell us what led you to ask the questions I just talked about? That ask the questions for this scenario. I think it's also mildly related to your earlier paper that's from ICLR 2019 titled "Equi-normalization of neural nets." We'll have it linked in the description of the podcast.
Yeah, so basically one of the main link or red wire of my PhD is the study of the over-parametrization of neural networks.
Okay.
And you can leverage it in many ways. You can use it to improve the optimization procedure of the neural network. So this is what we do on the iClear paper. You can also use it, leverage it to quantize, so compress networks. Basically, the idea came from one of my PhD advisors, of course.
Okay.
But yeah, it's kind of linked to the previous one. So if you basically if there is some redundancy, why don't we quantize, but in a data dependent way the network?
Okay. Also, going back to the question, so like, how does this research pipeline usually work? Maybe you, when you're discussing with your advisor, you ping back and forth a bunch of ideas, and when it sounds interesting to both based on your intuition, then maybe you prototype. So maybe
Yeah,
if you could
exactly.
talk.
I think, for example, for this project, I spent like 2 months talking like every day to one of my advisors at least. So
Okay.
it's the advantage of having like 3 advisors. One is always available, hopefully. So I go to the available one and ask the questions. And also they have different expertise. So depending on the problem I have, I know which one to contact first,
Okay.
preferably. But yeah, the idea is to speak like every day to give. I mean, I don't try to wait for the perfect result or the perfect setup with the perfect experimental conditions. I just throw the results at them basically, and
Right.
then we discuss them. And it's like, and often during the discussion we had some good ideas to when we were blocked and when we didn't know what to do.
Okay. Also, so if you could tell us more, during these 2 months, were you also like constantly prototyping as you discussed and like then discussing the results with the advisor, or how was that
Yeah,
period?
basically I was coding every day or every night depending. I was so yeah. The advantage of prototyping also is that you get results in like 1 or 2 hours. So for example, here I was working with Cypher 10 and a small cornet.
Yep.
And then you can get a feeling of what is working. And once this phase is over, then you go to the real world settings, so meaning ImageNet and ResNet, for example.
Yeah.
And then you adapt all the hyper parameters. You check that your intuition on the small models are right. And then also going back and forth, but then one training takes like 1 or 2 days, so you have to be a bit more organized, I would say.
Got it. So I'm also curious. You in the paper you mentioned that the results and speedups are indeed very exciting. They are double digits, not just percentage, but double digits for ResNets. So do you think these techniques can also be extended to outside of ResNets to other ConNets?
Yeah, of course. Actually, we extended it to Masker CNN in an updated version of the paper. So it's, the model is also available online because Masker CNN would be helpful for everyone working with vision and video, for example. So we managed to get Masker CNN into like roughly 6 megabytes versus 170 megabytes. But then I should say there are multiple approaches to compressing neural networks. So ours is doing quantization, vector quantization. Other people are just trying to design new architectures. So think of mobile net, efficient net also.
Efficient. Yeah.
And some people are also doing pruning. So like the things that to remove the connections.
Right.
Some people also are doing like hardware dependent quantization. So you have some specific hardware on a chip that will be on like a drone or someone.
Also
or
for
something.
TPUs maybe at
Yeah, for TPUs, but for smartphones or also maybe you want to adapt the compression rate to the hardware you have while maintaining a constant inference time. So it's nice work by Songan and his team at MIT.
Okay.
That people also should check. So it's not just to give you an overview of the field, and that maybe by combining some of the methods you get the best compression ratio.
Okay. So you've also provided an open source implementation titled "Kill the Bits." So first question is, where did the name originate from, and if you could also tell us a bit more about the code base.
Yeah. So basically, the name is also for my supervisor. So the same that found and the bit goes down.
Okay.
It was really on fire that day. Basically, the idea is to provide both the code for reproducing the results on the paper, so the whole pipeline for quantizing, but also for people that don't have the resources of all the time, just provide the compressed models,
right?
And you can already perform inference on them. So those are the two aspects, and we have two branches: one branch for the ResNets and the other one for the Mascarcian.
Okay.
Basically. But every contribution, of course, is welcome. As the code is not perfect, but at least it's out there, so it allows people to prototype like more easily.
Got it. Could you maybe tell us like how much refactoring do you usually do when releasing an public open source version? So like during research, you of course want to be like prototyping really fast. So how much refactoring does it take afterwards?
So basically on the iClear project, so the enorm thing, I did a lot of refactor because I didn't develop my code like as clean as I would want it. So basically it was a mess. So I had it took me like some days to refactor. On this project, I basically did nothing because I forced myself to have like a reasonably clean code that could be open sourced at every time.
Okay.
So it saves me a lot of time actually at the end. Not only for the cleaning part, but also for the researching part. Because if you have a clean and modular code, you can prototype more easily, I think, in the
Otherwise,
end. So,
you may forget who wrote this code and what version of me had written this code. I mean, that happens for me.
Yeah, it happens to everyone, basically. It happens to me also quite a lot of times. And sometimes the only thing refraining you from testing one ID is just, I don't want to modify the code. It's like 3 files. I get to this parameter. I want to get it to all the functions up to down to the function I want. So one of the main blockers actually is when you have like a code that is not modular as modular as you want, you would test less ideas, which is of course very bad. So I think in the end you will get the advantage of a reasonably clean code.
Okay, got it. So in the paper you mentioned running the quote unquote optimization code, like which compresses the model, takes around 1 day on a V100 GPU. For the audience, like could you help us understand how long is this compared to like the other approaches we were just talking about?
Yeah, of course. So yeah, sometimes people are quite kind of off the grid when thinking about training times. So let's say that in general, as a general guideline, training a model takes like a couple of days on a couple of GPUs. So it's pretty loose. But let me give you some more specific examples.
Leaving out BERT and XLNet totally out of the picture, it takes a few days, let's assume.
Yeah, of course. So if you want to train a ResNet or ResNext on ImageNet on like 8 GPUs, it would take you like 1 day, 1 or 2 days.
Yeah.
But if you want to train a very large NLP model with huge transformers on a huge dataset, it can take up to 1 or 2 weeks.
Yeah.
Think of GPT-2, for example. On the contrary, what people must realize is that the training a small ConvNet on Cypher 10, for example, takes like less than 1 hour.
Yeah.
So for prototyping, and this training this model on this particular dataset on Cypher 10 years ago took like I don't know days. So
yeah.
It's also interesting to see the progress, how fast the progress have been made.
So after compressing, do you think you mentioned the code base that we can run inference on the CPU and GPU? Does like the compressed model have a like equivalent inference time, or do you see a difference when doing that?
So for the moment, the inference function is more a proof of concept. So in the function, I just re-instantiate the whole network, so the non-compressed network, based on both the centroids and the assignments. So the inference time is the one of like a non-compressed ResNet on CPU or on GPU. So CPU will be slower, of course. As a future work, what we can do is that do the inference more in a more clever way, meaning that if you have the centroids, you can pre-multiply them with the activations and then just do the summations using the assignments. So we have a faster way to do so without instantiating the whole network, because of course it's useless on the mobile device. But it's more a proof of concept for the moment.
Okay. Curious about your thoughts, maybe unbiased thoughts on PyTorch. So what do you think about the framework? And I'd also like to point out a little nerdy detail that I noticed. I think it was issued at the cutting edge version, right? So it was a post 2 version back in the day when I think that was the cutting edge version of PyTorch.
So basically, PyTorch is amazing. So it's a non-biased, of course, evaluation.
I'm totally with you on that.
But I would say that it allows both for quick prototyping, if you know Python, and also it allows you to scale things up to production. So both those aspects are implemented in one single framework. So it's amazing. You should check out the websites and the tutorials. Of course, at FAIR, we are very supportive. And we also had with the beta version. So actually, the beta version came out when I was doing my internship, if I remember. So like only 2 days ago, 2 years, sorry. And basically we had by dogfooding the version at FAIR, for example. But I would say a huge thanks to the PyTorch team, because they are amazing and they are working like so quick. So especially Sumit Chintala and Adam Pasque. I think they are doing incredible work. So thanks to them, basically.
Even I think the community, I'm sure, is very thankful to them. I'm also curious, does FAIR help PyTorch also? How does the process work? So because I'm sure the research would contribute to PyTorch. Is it also driven by FAIR research?
So I think we have in 2 ways. The first is that we want specific features for our research. For example, there wasn't a fast Fourier there wasn't I think a fast Fourier transform before the version 1.0, I think. Maybe I'm wrong, but I think at some point we integrated the fast Fourier transform because we needed it. So the first point is incorporating features. The second point is just getting PyTorch the exposition, because when you open source code, that is of course in PyTorch. With projects such as mask RCNN benchmark, face, fast text, and so ever. We write a part of the code in PyTorch at least, and that incitates people, of course, to use PyTorch.
Okay. Going back to research a bit, so I want to know, like, in all of your preprints, you had multiple authors. So could you tell us how does a research situation in like a multiple paper author look like? So how do you like invite other researchers and distribute your work among them?
Yeah, so so basically, so first of all, I have to thank my collaborators, of course, because without them, I couldn't have done anything, basically. So I have three advisors. So Rémi, Hervé, and Benjamin on the paper. And basically, because they are my advisors, they all are in the paper.
Right.
We also worked with Armand Joulin, which is also at FAIR, and he already had experience in neural network compression with a repository called Fast Text. So for sentence representation, it's amazing. So his involvement was quite natural and also fruitful. And regarding the order, generally you put the researchers that had the idea at the end, or the most senior one. And at the beginning, you put the ones that contributed to most of the project daily, basically.
Okay. Got
So it's a guideline, but you have lots of subtleties in the field.
it.
But basically that's the guidelines.
Okay. How do you just out of curiosity? So I know about Kaggle distribute work differently, but in a research, so how do you distribute the collaborative effort? It depends on the experience, or how does that work?
Yeah, it depends entirely on the collaborators. Um, as a general guideline, I would say that the most senior ones um, basically don't code that much. Of course, they want to code, but they don't have the time, basically,
Yeah,
because they supervise many projects.
I can imagine.
So they are more on the storytelling side and
Mhm.
also on the basically having the ideas, which is
Right.
kind of important.
Mhm.
Also helping writing the paper because they have the experience to do so.
Mhm.
And the first authors in the paper have more hands-on experience with the code
Okay,
and the results in general.
got it.
So it's a general tendency.
Okay. Um, Now slightly shifting gears. So you've had as he said, a quote unquote traditional background. Do you think an only MOOC educated, which I've gotten really big recently, so online courses, educated person would be eligible for working in research? And how does such a person cultivate a research mindset, something that they might miss out?
Yeah, so I think basically what all it takes is just hard work and passion and curiosity. So the people working in ML have a lot of chance because you have lots of resources out there. You have, of course, the papers. You can read them. If you don't understand, there's nothing wrong with it, basically, because as a researcher, we don't understand anything. So everything, not anything, but everything. You can check the Medium post. You have the YouTube videos. You have lots of resources to your that you can use and
Mhm.
leverage.
Yep.
What really helped me is to work with other people, not to work alone,
Mhm.
both as a student and also as a researcher, by the way. But back when I was a student, I remember always working with one particular person, and we would study we had the same interest, but study slightly different things. And then we can learn from each other and learn the best practices, learn how to code. So
Right.
I think working in group is very both motivating and also fruitful.
We've also had this discussion on the series. So we were talking with Tim Detmers and Edward Harris, who's the CEO of Sharpest Mind. They talked about being accountable when doing a group study also helps. So I think that also contributes to the motivation factor as
Yeah,
you're
yeah, of
talking.
course. Study groups and also reading groups are very nice. For example, at Fair, we meet every week with the interns and the PhDs,
Mhm.
and we just discuss things. So sometimes someone presents their work, sometimes it's another paper, sometimes we just discuss ideas.
Right.
Um, I think it's so we shouldn't neglect that. So it's not that we have one breakthrough per session because it's not the case. Sometimes you feel you did not learn anything, but I think it's worth doing because sometimes it will really help you have another view of some topic and get some new ideas.
Okay. I'd
So
also give a
this is important, yeah.
okay. I'd also like to give a shout out to a community that I'm active in. So dsnet.org, dsnet.org. You can join that for online paper reading groups and study groups. We do that each week if the listeners are interested.
Yeah,
Uh,
so I think it's one of the best way to keep up the fast pace of the field and to learn things.
yep. Also, personally, I find the online ones slightly easy because I can sit at home with convenience and also be accountable to other people.
Yeah, it's kind of another motivation when you go back to home. When you go back home, if some people are expecting you to do something, you will be more keen on doing so.
Yeah.
So yeah, it's very nice.
So you just mentioned about the reading groups at Fair. Could you tell us how do you keep up with the exploding growth in research? So you didn't you mentioned you don't read a lot of papers. What other sources do you have for keeping up to date?
So yeah, I should read more papers, but for the moment, I rely both on my advisors
Hmm.
because they have the kind of an overview and they can very quickly sort out what papers are important and what papers are not, or less, actually. I also talk a lot with my colleagues because they are from different backgrounds, different research areas. So it's very nice to keep up with the new ideas. For example, when the transformers came out, some of the students explained to me because I wasn't aware of that because I work mostly in vision. And the third thing is to have a good paper manager tool. I would say I use Archive Sanity Preserver, so by Carpati, which is pretty good, I think. I should use it more. But once you have populated your library, I think the recommended papers are quite close to your interests. So on the bright side, you have all the papers that you care about in one place.
Right.
On the downside, maybe you are trapped in a bubble when you only see your particular research, and not the one from the others. So I would recommend also that people read articles that are not related directly to their small expertise. My expertise also is small, of course. So related to one's expertise, and because sometimes it gives you like better ideas or better perspectives on what you're working on.
That's a great insight. I think also for like people who aren't lucky to have advisors, Twitter serves as a great filter. Like if you follow your favorite researchers, that also acts as a good filter for me.
Yes, of course, because Twitter will, at least you will have the most discussed papers.
Yeah.
And I think in Archive Sanity, you also have the top hype, which are the most tweeted papers, I think. So yeah, definitely Twitter. And also Twitter is a good place to discuss quickly with people.
Yep. Quickly and concisely.
Yeah, so you have every... the nice thing is that everything is public, so you can discuss with anyone.
Yep, got it. So before we conclude, could you share any tips for beginners who are looking to get started in deep learning, and also your best advice for future-facing researchers in the field?
Yeah, so I think my advice would be kind of common, and I'm sure people already heard it, but I think it's not. It's worth telling that again for those who listen. So the first one would be not to be afraid to ask questions.
Yep.
Because if you ask yourself a question, there is a good chance that someone else also out there is asking the same question exactly, but is afraid of doing so.
Yep.
And also, we can keep in mind that that good research directions often start from very simple observations, and that people use to neglect. So basically, curiosity is one of the main drivers of research. So you have to even to force yourself to ask, or to always ask questions. The second thing would be, of course, to have a hands-on experience, so to learn every day. So of course, the reading groups are very nice for that. And also, you should start by implementing something that you know works. So like a simple classifier on MNIST or Cypher10, with your favorite library. And then build up on that. Don't begin by implementing, I don't know, the GPT-2 or a big thing on HD images. I mean, it won't work. It's totally normal that it won't work. So one of the key of research is just to build upon the work that people did.
Right.
So just clone repos and run them and modify the lines a bit, some lines a bit, and just see what's going on. And also the third thing, which can sound pretty boring, but actually it's true, at least from my perspective, is just to learn the basics of linear algebra, statistics, probability. Because then I think even, people often say that, but I think it really helps you first debug the code, because if you have an error, you will, if you perfectly understand what's going on, you will be able to debug more easily.
Right.
And also
iterate faster compared to like getting stuck on that annoying little problem.
Yeah, because you will have an intuition of what's going on, and also it will help you. It will help you like distinguish signal from noise, because statistics are exactly that, basically. So the point where you want to do to know if an improvement is significant, for example, is totally up to statistics. So just to get a feel of what it's like, you should definitely study the basics and master the basics.
Okay. I think that's great advice. So thanks for that. Before we end the call, what would be the best platforms to follow you and follow your work?
I think it's Twitter, as everyone, as in everyone. I regularly post the papers, the code, and also the blog post on the Facebook blog.
Okay.
So it's I think it's Pierre Stock on Twitter. Not sure. I think it's
we'll have it linked in a
okay. Thanks, because I know my Twitter by heart.
Okay. All right, Pierre. Thanks so much for joining me today, and thank you so much for doing this interview.
Thank you so much for you.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review, or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.